All right, let's talk about weighted mean. A weighted mean is just a weighted averaging where you one score or one thing may weigh more than the other. So weighted averaging is a method for computing an average where some values receive greater weight than others do. So um, just like your power schools grades, for me, my tests count like 60%, and my daily scores count for only like 35. So my tests really weigh a whole lot more. So if you do poorly on the test, it's going to really affect your grade. To me, tests really should uh, are the only things that really reflect your grade. The daily stuff is what it's just practice, and it's just a reflection of if you're learning or not. But the tests show whether you master or not, which is why I put more weight on the test. All right, but let's go on. It says to find the weighted average of a data set, all you do is multiply each value by its weight and add the products together. And then you're going to divide by the sum of the weights. Okay. And this is actually how we calculate your grade in Power School. So I'm going to show you that today. Okay. All right. Let's start off with example one. I won't do the Power School thing right now, but we'll start off with example one, and you'll have an idea of what weighted averages are. All right. It says a new car salesperson sold on average of $28,000 per day. Wow. For the first 5 days she worked, and then the next 3 days she worked, she sold on average $42,000. So how much did she sell on average per day over the entire 8 days? So I'm looking for the average sales per day. Okay. So let me get her sales. Okay. So all I'm going to do is I know she sold $28,000 five times. So I'm going to do 5 times 28,000. Basically, we've done this when we did the frequency charts, the frequency table. Like when we did, let's see, what was the frequency table at? Here. This is also a weighted average because this number happened 3 times, this number happened 9 times. So this is 9 times the weight of that one. Um, this number only happened 5 times, so it's weighted differently. Okay, let me get back to my example. I'm sorry, I got off track. All right, and so this woman made $28,000 per day for 5 days, plus she made 42,000 3 days in a row. So that's going to be 42,000 that happened 3 times. All right, and what I want to do is divide by 5 days plus 3 days, which is 8 days. So I'm going to figure out her average sales per day. All right, so let's take 28,000 and we get 100 and multiply by 5. We get 140,000 plus 42,000 times 3, which is 126,000. And when we add those together, we get 266,000 divided by 8. So the average car sales per day would be $33,250 per day. So weighted mean just means you have to multiply the numbers that repeat by the number of times they repeat, okay? Like this number repeats 5 times, so 5 times that number. This number repeats 3 times, so 3 times that number, and you divide by the total number of numbers. This happens 5 times, this happens 3 times, that's going to be 8 numbers. All right, Kelly works 2 jobs. She usually works at a retail store for 7 hours during the day and is paid $12 per hour by the store. She works 7 hours and paid $12 an hour by the store. All right, and then in the evening, She works as in a restaurant as a manager for 5 hours and is paid $20 an hour. So how much does she make on average for the day? Okay, so I know that she's going to be paid $12 7 times because she's getting $12 for each one of these hours. And then I know she's going to be paid $20 5 times because it's $20 for every hour. Now we want the average pay per hour. So this is going to represent our pay. And on the bottom, we need to put the number of hours. She worked 7 hours and she worked 5 hours. So that means throughout the day, she worked 12 hours. Okay, so I have 7 times 12, which is 84. 5 times 20, which is 100. Divided by 12. So I get 184 divided by 12. And so we can say on average per day, she is making, for that day, she made $15.33 per day, but specifically for that day, okay? All right, let's take a look at 3. James works for 12 consecutive days, earning an average wage of $160 per day as a contractor. It's pretty good. All right, during the first 6 days, he averaged $140 per day, and his average wage for the next 5 days was $175. Okay. All right. So how much did he earn on the last day? Okay. All right. So 6 days at $140 plus. No. Let's see. During the first 6 days was 140, and then the next 5. So 5 days at $175 plus that last day at, I don't know, some amount of dollars. Okay, we don't know, so we're going to put an X. All right, but I do know he worked a total of 12 days, and his average for all of those equal to 160. All right, so I'm going to set up an equation here. So this is how we're going to do this. I am going to say 6 times 140 is 840 plus 5 times 175 is 875 plus some amount for one day. I don't know, some amount. All divided by 12 equals to 160. So I have 840 plus 875 is 1715 plus, instead of 1x, I'm just going to put x, divided by 12 equals to 160. So basically, I'm solving this one-step equation. I'm going to get rid of this 12. First of all, I'm going to multiply 160 times 12. And 160 times 12 on this side. These are going to cancel. So I end at 715 plus x. And when I multiply 160 times 12, I get 1920. So now all I have to do is subtract that 1715 from both sides. And I know on that last day that he made $205. All right, guys. I hope that makes sense. So, if you go in here and you put on that last day, he made $205. Let me show you. Let's take this out. Because 1 times 205 is 205. I'm just going to show you this checks out. Okay. And it should equal to 160 because the average was 160. All right. So if you take 840, add it to 875, and then add 205, you get 1920 divided by 12 and it equals to an average of $160. So he had to make $205 that last day, okay? Let me put the money symbol on this. Okay, let's take a look at 4. So I'm going to show you how to do these PowerSchool grades, okay? We're going to use the following information to find your course average for Mr. Tate's class. So for homework, these are the grades you've made. For class participation, you made those two. The test grades, those are your grades. And then here's your final exam. Okay, so for homework, he only counts it worth 25%. So he takes 25% of the average. All right, for class participation, he's going to take 10% of the average. For your tests, he's going to take 40% of the average. And for that final exam, it's going to count for 25% of your average, okay? And so, guys, when you add these things up, it's all going to be 100%. All right, first of all, I'm going to find the average for these tests, okay? So, for the homework. So, for the homework, I'm going to do HW. So, I know that's going to be 83. Let's find the average there, plus 92, plus 95, plus 90. And I'm going to divide it by 4 grades. Okay? So, we got 83 plus 92 plus 95 plus 90. That's 360 divided by 4. So your homework average is a 90. Okay, class participation, we're going to call it CP. So you got 2 grades. You got, which they added to 190 divided by only 2 of them. So if you cut 190 in half, you end up with a 95. So your average there is a 95. And then your test grades, let's see, you got a 90, 90 plus 78 plus 84 plus 88. And we're going to divide it by 4. Let's see what we get. 90 plus 78 plus 84 plus 88 will end up being 340 divided by 4, which is an 85. So your average for the test is an 85. And of course, your only grade for the final exam is an 84. So what I'm going to do now is I'm going to find 25% of whatever my homework average was, which is 0.25, times whatever my homework grade is, which is a 90, plus I'm going to find 10%, which is 0.10, of my class participation average, which is a 95. Plus, I want 40% of my test average, so that's 0.40, or 0.4 of an 85. And then lastly, it's 25%, that's 25. 25%, so that's 0.25, and I'm going to need a little more room. 25% of that final exam, which was an 84. And altogether, that's going to represent 100% of the number 1. So these are percentages. So this is 100%, which is just the number 1 itself. 100% is 1. So basically, we're dividing by 1. Because you can say I'm dividing by 100%, but 100% is 1 whole. But we don't really divide by the 1. I just want you to understand, you are still dividing by whatever this is, which is 100%, but 100% is 1, guys. So basically, all you're doing is figuring out 25% of 90. So I'm going to punch in 0.25 times 90. That's going to give me 22.5. Plus 10% of 95, which is 9.5. Plus 40% of 85, which is 34. Plus 25% of 84, which is 21. And like I said, you can divide by 100%, which is still just 1, but I'm just going to leave it like this. You can do this, divided by 1. You divide this by 1, because the 100% is just one whole grade, okay? It's one thing. If you add up 0.25, 0.10, 0.40, and 0.25, you're going to get 1, guys. It's like a quarter plus a quart is 50 cents. And 40 cents plus 10 cents is another 50 cents. 50 cents plus 50 cents is that dollar, okay? All right, so let's take 22.5, add it to 9.5, add it to 34, and add it to 21, and we get an 87. Now, everybody knows 87 divided by 1 is just 87. So for Mr. Tate's class, you will have an 87 for your final grade. And that is how we do it in Power Schools. All right, let's take a look at 5. You work for a product testing company and are recording information for a taste test. The ages of the participants are shown in the table. You're going to calculate the average age of the participants. Okay, so I'm looking for average age of participants. So I know I'm looking for age per participant. So my ages are going to go on the top, and my participants are going to go on the bottom, the number of people. So let's take a look at the ages. Well, 8 people are age 22. So let's do that. 22 is going to appear 8 times. 9 people are age 23. 4 people are age 24. 3 people are age 25. And 1 person is age 26. And what you're going to do is divide by the number of participants or the number of people. Let's see. Let's look at the total number of participants. 8 plus 9 is 17. 17 plus 1 is 18. 18 plus 3 is 24. And 24 plus 4 is 28. So 17, 18, 18 and 7 is 25. 17, 18. 18 and 3 is 21. 21 and 4 is 25. Okay, so we're going to divide by 25. And do 8 times 22. That's 176. Plus 9 times 23 is 207. Plus 4 times 24 is 96. Plus 3 times 25 is 75. Plus 1 times 26 is 26. All divided by 25. Okay? So you got 176 plus 207 plus 96 plus 75 plus 26. So you got 580 divided by 25. So that would be 23.2. Okay, is the age. I'm going to say around approximately age 23 per participant. I'm just going to round that off. Now, when you're working on your Edgenuity, you look at your choices. If it's running to the nearest tenth or whole, you can kind of see what to do from there, okay? All right, you own a jewelry store and have been collecting data over the last month on how many watches you sell per day. So I'm looking at watches sold per day. I already know this is going to be watches sold per day. Watches on the top, days on the bottom. Given the table, what is the weighted average for the number of watches sold per day? So let's take a look at this frequency table. 10 days. For 10 days, on one watch was sold. So one is going to appear 10 times. Okay. For 11 days, 2 watches were sold. So that 2 is going to appear 11 times. For 6 days, 3 watches were sold. So 3 is going to appear 6 times. For 2 days, 4 watches were sold. So that 4 is going to appear 2 times. And then only 1 day were 5 watches sold. And we're just going to divide by the number of watches, the number of days. So we have 10 and 11 is 21. 21 and 6 is 27. 28, 29, 30. So we got a total of 30 days. It just has to be for the month. Yeah, that last month. So I have 10. 1 times 10 is 10. 11 times 2 is 22. 6 times 3 is 18. 2 times 4 is 8. And 1 times 5 is 5. Divided by 30. So we got 10 plus 22 plus 18 plus 8 plus 5 equals 63. Okay, make sure I counted that all right. So we got 22 plus 10 plus, I'm going to go ahead and say that's 26 plus 5, 63 divided by 30. 2.1. So on average, 2.1, you can't say a 0.1 of a watch. Doesn't make any sense. So we'll say approximately 2 watches. Come on. Okay, 2 watches per day were sold on average, okay? All right, so it says you own a home improvement company and are calculating the weighted average of doors sold over the last week. So we're talking about 7 days. Which expression could be used? I'm not going to do which expression. We're going to write an expression that could be used to calculate the weighted average. Okay, so we're looking for the doors sold over the last week. So the average of the doors sold over the last week. So that would be in days. Doors sold per day. All right, so I know for 2 days, 1 door was sold, so that 1 is going to appear 2 times. For 3 days, 5 doors were sold. For 2 days, 3 doors were sold. And that's over a course of 7 days. That would be the expression you would use, okay, to calculate the weighted mean. Instead of would, I'm going to put that could. Write an expression that could be used to calculate the weighted mean. That would be it. All right, so the last two things I have to cover are tolerance and measures of spread. But I'm going to go ahead and cover tolerance. It's pretty simple. It's only one little page. Okay, let's get tolerance out of the way. So what is tolerance? So tolerance is the total amount of dimension. The total amount a dimension may vary, and is the difference between the maximum and the minimum limits. Basically, it's like a range. It could go so far above or so far below the lowest or highest number. Because in real life, it's impossible to make everything to an exact size. It's going to be some discrepancy to whatever you're measuring to trying to make. Okay, because we're not perfect, so we can cut things or make things as kind of close to what we want, but it won't be perfect. Okay. All right. In the factory where you work, the specified diameter of an iron dowel is, and a dowel is just like some little cylindrical piece of metal, is 0.35 inches. Okay, so the diameter. So I'm gonna show you what we're looking like. Let me make that look a little better. So let me show you. Diameter would be let me make this thinner. The distance from here to here. From one end of the circle to the other end of the circle through the center though. And it can be shown, diameter can be shown on the top or the bottom. So the diameter of this dowel is, I'm gonna call it D for diameter, is 0.345 inches. So it's that many inches across with a tolerance of plus or minus 3 inches. What would be an appropriate range of values for the diameter of the dowel? Okay, so like how far could it go above or below? So it says plus or minus 3/100 of an inch. So we can add 3/100 of an inch to it, or we could subtract 3/100 of an inch from it, from the original diameter. And that would be the play that you have in that for the diameter of that dowel. So that's 5, 1, 3. That's going to be the minimum value. And here, 5, 7, 3. This is going to be the maximum value. So when that dowel is made, it can range from 315 thousandths to 375 thousandths, and it should be in terms of inches. But we would like to make it that many inches, but sometimes, that's just not possible for us to do that. So it can be off a little bit, okay? Because we can't always make things too exact. So we give it a little room for play. So that means this is acceptable. If a piece has a diameter that is 315 thousandths inches, they'll still let it pass because that's the range, plus or minus 3/100 of an inch. You can be off. You can be 3/100 of an inch below the normal diameter, or 3/100 of an inch above the normal diameter. B, you perform quality assurance for a sporting goods company. A baseball is supposed to have a diameter of 2 9/10 inches, with a tolerance of 400 inches. A single ball is packaged in a plastic wrap to 500 inches thick. What is the greatest possible diameter in inches of a wrapped ball? You got to consider this wrap then that you should accept. Okay, so all right, so the tolerance is plus or minus 400ths of an inch, but you're looking for the greatest possible diameter. So I'm going to take the original diameter, and since I'm looking for greatest, I'm going to add 0.0400. So if I were looking for the lowest, I would subtract that from 2.9. Okay, so it looks like the greatest possible diameter is, why am I subtracting? I need to add. I'm so sorry, you all. I don't know. I just gave you all the lowest. Okay, so the greatest possible diameter is 2.94 inches. Okay, but you're going to have to consider you got this ball. I'm not too good with it. Let me see if they got a shape. Take the ruler back. I'm looking for shapes. Okay, let's do this. All right, so you got this ball here that is, let me go back to shapes, that has a diameter from here to here. And we're pretending like we're going with the greatest possible diameter. So we're going to go with, it has a diameter of 2.94 inches. But there's a wrap around the ball, okay? And the wrap is 500 inches thick. So that means that when you wrap this, okay, so let me go with this as the wrap. Okay, we're gonna pretend that we're putting some wrap around this. Okay, let's do the wrap. I'm gonna do the wrap in pink. Okay, so we're gonna do this wrap around it. God, now, I don't know why they did that, but ignore it. So this pink represents the wrap, okay? Okay, all right, now I want you to keep in mind that this wrap is this thick. So from here to here, it's an extra 500 inch, okay? But that's not the entire diameter. You also have it wrapped all the way around the ball, so you got to consider this part. So you got to go, that you got to consider from here to here is also that thick. So the entire diameter with the wrap on it will not only be this 2.94 inches, but these two 5/10ths of an inch with the wrap, 500ths of an inch with the wrap on it. So I'm going to do 2.94 plus 500ths from one side from the wrap being that thick, and 500ths of an inch from the other side from the wrap being that thick. So that's 14. Here's the one that's 10. Here's the one that's 3. So the greatest possible diameter of the ball, of a wrapped ball, is 3 400 inches. Okay. All right, guys, I'm going to stop this video. And the last video I'm going to make in the statistics unit is on standard deviation and range.